Today we are going to do 4 more examples on how to determine the end behavior of the graph of a polynomial function. If you are not confident with this topic, feel free to watch my previous video. Let's start with f of x equals x cubed plus 2x squared minus 3x minus 4. The sign of the leading coefficient is positive, and the degree of the polynomial is 3, which is odd. Odd degree polynomials have graphs with opposite behavior at each end. So the graph of this function falls to the left and rises to the right. Let's look at the next example. G of x equals the negative of 2x cubed times x minus 1 in parentheses squared times x minus 5 in parentheses. I really encourage you to pause the video and try this on your own. The degree of this polynomial is not 3. We have to be careful here. Note that there is no addition or subtraction sign between these terms. Recall that when multiplying exponential expressions with the same base, we add the exponents. This means that the degree of this function is 3 plus 2 plus 1, which is 6, which is an even number. Even degree polynomial functions have graphs with the same behavior at each end. Without multiplying out, we can see that the leading coefficient is -2, which is negative. So the graph of this function falls to the left and falls to the right. What about h of x equals the negative of 9x cubed plus 6x squared plus 7x plus 4? The degree of h is 3, which is odd. Odd degree polynomial functions have graphs with opposite behavior at each end. The leading coefficient is -9, which is negative. So the graph rises to the left and falls to the right. Let's look at the last example. I of x equals the negative of x to the 4th plus 8x cubed plus 4x squared plus 2. The degree of I is 4, which is even. Even degree polynomial functions have graphs with the same behavior at each end. The leading coefficient is -1, which is negative. So the graph falls to the left and falls to the right. I highly recommend putting these functions into a graphing calculator and trying different signs and different exponents of the leading terms to see how the graphs change. Make sure that you use a viewing rectangle that accurately shows the graphs and behavior. If the viewing rectangle is too small, it may not accurately show the complete graph with the end behavior. If you like my videos, like, share and subscribe. Thanks for watching and happy learning, everyone.